let's do the problem shortest bridge on LeetCode. So this is a pretty good problem because it helps you practice DFS and BFS, which are both really common in interviews. And so if you're comfortable with that, then this would be a good problem for you to do. So let's read it. You're given an n by n matrix where 1 represents land and 0 represents water. An island is a 4-directionally connected group of ones not connected by other ones. There are exactly 2 islands in the grid. You may change zeros to ones to connect 2 islands to form 1 island. Return the smallest number of zeros you must flip to connect the 2 islands. So let's draw that. So let's say you have this for our first example here. So 0, 1, and 0. Okay, and so it's pretty easy to visualize these. So a group of connected ones would be here and then here. And then the shortest distance in this problem is just the number of zeros between the 2 islands in the shortest path. And so here would either be this path or this path, and it would be 1. So let's try to draw one more. It's the second one. Okay, so our islands here are this and this. And the shortest path would be this would be 2 zeros, and this would be 2 zeros. So either way, it would be 2. Now, in these two examples, your island is only 1, 1, but you can have the case of your island being a bunch of ones. So for example, let's say you have something like this last example, where you have something different. So your ones, I'm just going to draw another color actually. 1. And then you have another island in the middle here. And then these are all zeros. So let's draw that another. Okay, so in this case, your island is this whole border, and then your other island is this one. Now, it doesn't really matter. Alternatively, what you could do is you could start with this middle island and go here. It'll be the same. But your shortest path is going to be this or this. All of these are the same, and it's 1. And so what you're going to want to do in this problem is you're going to want to search through the grid, just going down row by row by row, until you hit a 1. And then you're going to need to call DFS on this first one to get every single island that's connected to it. So if we call DFS on this one, then we're going to get this whole island here. We're going to need to store that in some kind of container, probably like a set. And then we're going to need to call BFS from every single point on the island. And whichever point we hit the second island from first is the shortest path. So let's write down our steps here. So 1, just go through grid. 1, call DFS on it to get island 1. Call BFS on that visited set, which is island 1, to get shortest path. So that's our steps. And it maybe is a little tricky to recognize that that's what you need to do, but for most of these LeetCode questions I found that have a grid and these island problems, almost all the time you need to do some kind of a BFS or a DFS, and there's various ones like walls and gates, or change every number not connected to a border to a 0, or things like that. These are the main ones you need, so just become familiar with them, become good at them. Now I will say with this problem, it's very easy to make mistakes in your code, so try to be careful there for sure. I've done it a few times. Okay, so let's code this up. So the first couple things you're going to want when you do BFS or DFS is you're going to want some variables that tell you how many rows and columns are in your grid. So in this case, they're equal, but we're just going to have them anyway. We could technically just have 1. And then another variable you want is you want a variable, you want an array, and it's going to have where you're going to need to be going. So you're going to need to go up, down, left, and right. And having an array for all of these directions is going to make it easier to code it up later on. So let's do that. And then we're going to have a visited set. So what we're going to do, and we need one more function actually. So when we look at these, let's say we're here, we might actually go out of bounds. So let's say we try to go left, we're out of bounds. We try to go here, we're out of bounds. So we need another function to check if we're in bounds. So we can call that bounds. So that's going to be that. Now let's write our DFS and BFS. For some reason this LeetCode is weird tabbing. Let's write our DFS and BFS, and then at the very bottom we'll just loop through this grid until we hit a 1. So DFS. First thing we're going to need to do is we're going to check if it's in bounds. So if not in bounds, row, column. And then the other stop conditions for the DFS are if it's in the visited set, that means we've already been here. And then the last one is if it's a 0, because if we take a look at our picture again, let's say we're here and we go here, we care about it, but if we go to some 0, then that's not part of the initial island, so we're done. So if grid. We can just return. And now we're going to use this direction array to go up, down, left, and right. And so we can have something like this. And because we have this sort of direction array, we don't need to do a +1, +0. We don't need to have the same statement multiple times when we're traversing. So for directions, we can just write this once now. Okay. And that should be our main DFS. So we check. Oh, wait, we missed one more thing actually. So what we need to do is we need to, once we get here, we need to add this place to our visited set, so then we make sure that we don't go here again. And then we're done with that. Now let's write our BFS. And our BFS, it doesn't need to take any input, but we are going to use our visited set. So when we traverse an island, we're going to have this island in our visited set, and then what we need to do is we need to take our visited set and change it into some kind of data structure that we can use for BFS. And the best data structure for BFS is a deck, because we're going to be popping from the left and appending to the right, which is the best structure in Python for that. And so we can just say something like this. And we're going to use our visited set. And also a nice little trick you can do with a deck is, let's say your numbers are this, and you're gonna you want to do something that calculates the minimum path or distance or something. There's two ways you could do this. One way is, instead of storing these numbers, you can store a number and a distance, and then every time you pop, you just add 1 over here, and then you push it again, and then that way you can keep updating it. Another way you can do it is you can have a for range loop, and let me show you that real quick. So you can, so we need to, while this deck is true, and we're going to have a output variable. This is going to be our output of the shortest path. So we can do something like this. Okay. And what this does is this takes a snapshot of how long the deck is in the beginning, and even though we're changing the size of it down the road, it doesn't matter. This will only iterate whatever the snapshot was. So let's say our deck here was 3 elements, but then we're adding 5. This will only pop 3 times. And so by the time it's done popping, our current level is done. So in this case, we would have this level with all these ones, and then by the time it's done popping, by the time we get through this loop, this level will be done, and then the next level will be in the deck that we're traversing. So we can do something like that. Then we need to pop left. And so once we pop, we need to do the same kind of thing with this direction thing. We need to get new directions. So just to look at the picture again, let's say we pop this one, we need to check here, 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 and here. And so first we need to check if they're a valid location, and then we also need to check, have we been here before? And if we've been here before, then we don't want to do that. And if we haven't been here before, then we have to check if it's a 0 or a 1. So if it's a 0, we need to add it to the deck because this is part of the bridge. And if it's a 1, then we're done. We've reached our second island. If it's a 1, that's not in our visited set. So let's do that. And we're going to use this direct. So this should actually be directions. Okay. And then I'm going to make a new row and new column here. So now we need to check, is it a viable location? And if it's not, then we don't need to do anything. So here we are going to check if it's actually inbounds. So we need, and it's not in our visited set. So now that we know we're at a 1 or a 0, if it's a 1, we're done. So we can just say that, because that means we've reached our second island. We can return here. Else, we know it's a 0, so we can just add it to our deck. And now, once we've hit the end of this for range loop, or range for loop, we can increment our res value because we went through one whole level in the deck, so our next level is going to have one more distance. And technically, we shouldn't need a default return value, but we can have it in there just in case. So it should never reach it though. Okay, and now the last thing we need is we need our loop to go through the grid. So that could be something like this. And remember from our picture, when we're looping through this grid, we just need to get to the first one, and then we call DFS and BFS. So this is 1, then we can do DFS. And we can just return the BFS. And so we don't need a return value because this should always happen. Okay, so let's try this code. See if we did anything wrong. I usually do stuff wrong on something like this. Okay, yeah, so a bit weird. And this new version of LeetCode, sometimes it tabs incorrectly for some reason. Okay, let's see what's this. Okay, this is that. Okay, now let's try to submit. Ooh, do we have a problem? Time limit exceeded. Interesting. Okay, let's see what we did wrong here. Just to double check. So this is all fine, visited. This is fine. If not in bounds, this is fine. That's fine. Res equals 0 for I. Direction. Okay. If in bounds, it's fine. Not in visited. Oh, I forgot one thing here. So what I didn't do that I forgot is if our new location is not unvisited, we need to add it to visited. And that's why it's too slow, our BFS is too slow. So let's just, okay. Grid, yeah, everything else should be fine. I'll just check this default one. Okay, and it should be good. Okay, so let's take a look at the time and space complexity now. So time, space, and let's go back to our picture for that. So our DFS, the maximum it can go, so this is n, this is an n by n matrix. The maximum it can go is n by n, and so our time complexity of DFS is going to be n by n maximum. Like if our island is most of the grid, that's going to be n by n. Our BFS is also going to be n by n maximum because we have the visited set, so we're never really revisiting anything that we already visited before. And then our nested loop that finds the first one can also go n by n, which means it's just this n squared. And then in big O, we get rid of that. So our time complexity is n squared. And then our space complexity, our visited set, can technically visit every single location here, which would be n squared. Our GFS can have a recursion stack that's worst case n squared, and then our BFS can hold at the most n squared as well. So it's the same thing, 3n squared, which goes to n squared. So this would just be squared, squared. I guess that's it for this problem. Yeah, just like I said, it's very easy when you do code this up to run into some issues, so be careful there. And I think this was a good one to do, and I'll do some others in the future. So thanks for watching.